we will start with the new topic of S block element, that is preparation and properties of some important compounds. Our first compound is sodium carbonate. Its molecular formula is Na2CO3.10H2O. It is also known as washing soda. It can be prepared with two major processes, solvay ammonia process and electrolytic process. We will first look into solvay ammonia process. The raw materials required for solvay ammonia process is NH3, limestone which acts as a source of CO2, and brine solution. Brine solution is aqueous solution of NaCl. So the reaction goes as follows: NH3 plus H2O plus CO2 gives ammonium bicarbonate. NaCl reacts with ammonium bicarbonate to give sodium bicarbonate plus NH4Cl. This sodium bicarbonate, when heated, gives sodium carbonate plus CO2 plus H2O. Various steps involved in these reaction steps are saturation of brine with ammonia, carbonation, filtration, ammonia recovery, and calcination. Now we will look into electrolytic process. In this process, NaOH is made to react with CO2 to give sodium carbonate. We will now look into some properties of sodium carbonate. Sodium carbonate is a white crystalline solid. It is decahydrate. On heating sodium carbonate, we get the monohydrate form of sodium carbonate, and further heating renders its anhydrous. The anhydrous form of sodium carbonate is white crystalline powder, and it is also known as soda ash. Our second important compound is sodium chloride. Molecular formula NaCl, and it is also known as table salt or rock salt. The preparation of NaCl. The most abundant source of salt is the salty water, sea water, inland salt waters or salt mines. On evaporation of salty water in open field leaves behind the residue of impure NaCl, which needs to be purified. So we'll look into purification of NaCl. Major impurities include sulfate of Na plus, Mg2 plus, along with the chlorides of Ca2 plus and Mg2 plus. Purification is done using the differences in solubilities and is based on fractional crystallization. Through the saturated solution of impure NaCl, HCl gas is passed and NaCl is precipitated first. Now we'll look into some properties of NaCl. It is a white crystalline solid which is soluble in water but insoluble in alcohol. It is the starting material for most of the compounds of sodium. Our fourth important compound is sodium hydrogen carbonate or sodium bicarbonate. Its molecular formula is NaHCO3 and it is also known as baking soda. Preparation of sodium bicarbonate. On passing CO2 through sodium carbonate, we get sodium bicarbonate, which is sparingly soluble in water. Industrially, it is obtained using solvay ammonia process as discussed earlier. Now we'll look into some properties of baking soda. It is white crystalline solid, sparingly soluble in water, and the aqueous solution is alkaline due to hydrolysis. Our third important compound is sodium hydroxide. Its molecular formula is NaOH and also known as caustic soda. Its preparation is done using Kastner-Kellner cell. Brine solution is electrolyzed with a mercury cathode and carbon anode. The sodium metal discharged at cathode combines with mercury to give sodium amalgam, Na amalgam, and chlorine gas is released at anode. The sodium amalgam is treated with water to give NaOH and H2 gas. Now we'll look into some properties of caustic soda. It is white crystalline solid, it is highly soluble in water, it is deliquescent in nature, and on exposure to atmosphere, it absorbs moisture and CO2 to form Na2CO3. Now we will look into next topic of S block, that is biological importance of sodium and potassium. Na plus ion participates in transmission of nerve signals, regulating the flow of water across the cell membranes, transport of sugar and amino acid into the cell. K plus ion activates enzymes and participates in the oxidation of glucose to produce ATP and is responsible for the transmission of nerve signals with the help of Na plus ions. We will now move to the next topic of S block, that is industrial use of lime. Molecular formula CaO. CaO finds its maximum use in manufacturing industries. It is used for manufacturing bleaching powder, slaked lime, calcium carbide, cement, glass, lime colors, and etc. It is used in basic lining in the furnace. It is used in the purification of sugar. It is used in water softening. It is used in conversion of sodium carbonate into caustic soda. It is used for the preparation of ammonia gas in the laboratories. Now we will move toward the next topic of S block, that is industrial use of limestone. Molecular formula CaCO3. CaCO3 is used in the manufacture of quicklime, slaked lime, washing soda, cement, glass, and high quality paper. It is the basic flux in metallurgy. Precipitated chalk is used in paints, toothpaste, medicine for indigestion, adhesive, and cosmetics. Now we will move towards the next topic of S block, that is biological importance of calcium and magnesium. Calcium and magnesium play a vital role in biological reactions. The main pigment which absorbs sunlight in plants is chlorophyll, which contains magnesium. Calcium is present in bone tissues in large amount. Calcium is also involved in enzymatic reaction related to storage of energy in forms of pyrophosphate linkage.
Thank you for watching. Visit us at needbook.in.